if you will. So lines, linear equations, are of degree 1. So lines have x to the first power right there, right? And so if you recall, when we're talking about lines, you have y equals mx. So the coefficient of the x is the slope, right? Now, why do they call it an m? If anybody knows French, you know the French word for mountain or incline is monter. And this was a French mathematician who kind of focused us on the slope. So he named it, instead of S, he named it M because he called it the incline or the mountain, the stairs, monter. So M stands for the slope. So if you remember, M is the coefficient of 3, and we use that as a rise over run. So rise is change in y, right? So some of you may remember from physics that this would be delta y over delta x. Okay? It's the change in y over the change in x. Some of you may remember this as rise over run. So if you have a negative, you would go down and then to the right, or you could go up and then to the left. So knowing all that, you have 4 different kinds of lines. You have lines with a positive slope. Those are slanted to the right. You have lines with a negative slope. Those are slanted to the left. You have horizontal lines which have a 0 slope, or you have vertical lines which have an undefined slope. Lots of people get these mixed up. This one is always y equals. This one is always x equals. Okay. Okay, so lines have x to the first power. They have 2 variables, y equals, and x to the first power. Now, this is what we're going to be doing after this next test, and that is things with more than 1 degree. Okay? So let's go on to the next slide. And again, I'm going to post this video so that you can take a look at it. So here we have from page 239, if you want to follow along. Actually, I don't want to do that yet. I want to do this. So, back to our overview. Degree 2. Remember, that is x squared, right? That is degree 2. And as you said a little bit ago, this also tells you how many changes in direction there are for your graphs. You see this has 2 directions. Here's the first direction. It's going down, and then the second direction is going up. So this is what we know as a parabola. And we did this on IXL. These parabolas had a positive leading coefficient. Do you remember? Started with a positive, and these had a negative leading coefficient. And it's not a quadrilateral, it's a, why did I write quadrilateral there? It's not a quadrilateral. This is a parabola. It's a quadratic, that's what I was trying to say. If it is quadratic, it is of degree 2. Okay? So these are quadratics. Now let's take a look. Is this an even or an odd function? Look at this. Is this an even or an odd function? This is even. If I fold this along the y-axis, it matches. So this is an even function. Now, this one looks even right now, doesn't it? But watch what happens if I change that, is that even now? Okay, the equation for that now is actually this equation. This makes it not even, because if I fold it along the y-axis, it doesn't match, does it? Okay, so just because it has one even exponent does not make it even. Because if you notice, this is the equation for this. This is a translation. This means that I've moved this to the right 4 units. And this is now my vertex. So this is a preview of what's coming next. The vertex is going to be obvious to you. Okay? And if I move this over here, this one would be the red one down there. I'm trying to get it lined up just right, and it's not moving. There it is. This one would be the red one down here. Notice that this one was positive, even though it looks negative, and this one is negative. So it's kind of the opposite of what it appears. But we'll go into more detail with that. But the bottom line is these are not even because they're not symmetric with the y-axis. And the reason they're not symmetric with the y-axis is because if you FOILed this, the exponent on the x would no longer be even. It would be to the first power, wouldn't it? Okay? So that's why that turned out to be not even. All right, let's take a look at this one. And that's what I'm telling you here. This one is even, but that's the parent graph. But this one, if I move it over 3 spaces, that is now that equation, and that makes it not even, because this is the equation for that. So you can see if I FOIL this piece, I get squared and now to the first power. So that makes that not even. 2, 3. So degree 3 is going to look like this. So this is what we call the parent graph for this one. It is just y equals x to the third. Okay? Is this even or odd? It's odd, because if I put my pen in the paper right there and I rotate that, didn't mean to rotate that. If I rotate that 180 degrees, then it will match. Okay? Plus, there's also no other exponent, is there? So this is an odd exponent, and that makes this an odd function. So polynomials can be of degree 1, 2, 3, 4, on to infinity. But this is actually even. Because if I fold this along the y-axis, doesn't it match? Okay? So it is, if this is the equation, this is y equals x to the 4th, and that's all there is to that one. So the only exponent is even. This one would be odd. This one is odd, and this one is even. This one. If I put the pen in the paper right there and I spun the paper around 180 degrees, wouldn't this now be on top of where the other one used to be? That makes it odd. If it's symmetric to the origin, it is odd. Okay? So, you should be able to look at any polygon and either graph it or look at the equation and tell why it's even, odd, or neither. Right? So, if I did have this one, let's see if I can get this one moved now, because I do want to move it now. What about now? Is that even, odd, or neither? Neither. And if it goes up, straight up, even, odd, or neither? Even. And what if it goes down and left? Neither. Okay? So this function is now even, isn't it? Okay? So you should be able to look at a graph or look at an equation and tell us something is even, odd, or neither. All right, so now we're going to go back to the lines, to the linear pieces, and we're going to do a few practice problems. If you want to open your book to page 239, let's take a look at some practice problems like the ones that I'm going to ask you to practice on. So, back to lines. A quick review. This should be an easy part of the upcoming test, because this is Algebra 1, by the way. So, we are given, and in the book, it gives you the points 4, 7, and 8, 10. And it simply asks you to find the slope. Well, I'm going to ask you to do a little more than that. I'm going to ask you to find the slope and write a linear equation. So we're going to follow the steps. We're going to find the slope. You find the slope by doing y1 or y2. Okay, so the first step is to find the slope. So let's do 10 minus 7. Remember, the change in y goes on top. And 8 minus 4. Now, I want to remind you that this is an ordered pair. 8, 10. And this is an ordered pair. 4, 7. And there's minus signs in the middle. So hopefully you can see that. So again, it was 10 minus 7 over 8 minus 4. And so the slope for this is 3/4. So we know a lot about this line already. We know that it is slanted to the right. Okay, we know that it's not a horizontal line, it's not a vertical line, because we didn't get undefined or 0, right? So we know that it is slanted to the right. We also know that there's only going to be one direction. It's always going to be increasing, it's positive. Okay? So, if you remember, I wanted you to write an equation, and the first step was finding the slope. The second step is to pick one of the points. Now, it doesn't really matter which one you pick. In fact, if half the room picks 4, 7, and the other half of the room picks 8, 10, you should get the same equation. So if you want to test that out, go ahead and test that out. I'm going to pick 4, 7. And I'm going to write my equation. So I'm going to pick 4, 7. And I'm going to use point-slope form. Now, this one might be new to you. But you need to write equations in calculus, and anytime you're ever told to write an equation for a line, you want to start with point-slope form, because it's just the easiest. Then you can manipulate that into whatever form the directions say. I'm going to have us put ours in standard form, which is ax plus by equals c, where a, b, and c are integers, and a is positive. So we're going to pick this one. We're going to pick 4, 7. And I'm going to use the formula y2 minus y1 equals m times x2 minus x1. Now, the most complicated thing is people want to put both points in. If you put both points in, you're not going to have an equation. You're going to have a number equals a number. So if you don't get an equation, most likely you forgot and put both values in. So I'm going to use big Y for my second point. So it's Y, so I can have a Y in my equation, minus 7. The 7 comes from here. Equals the slope. The slope was 3/4. And big X minus the 4. The 4 is the ordered pair. So, if I'm putting this in standard form, I now need to multiply this through. Okay? So, I think in the other class that I did yesterday, we actually did both of them. So, here is the 4, 7 one, and here is the 8, 10 one. So, no matter which one you pick, you're going to get the same equation. Right? So, we distribute the 3/4. 3/4 times x is 3/4 x. And 3/4 times negative 4 is negative 3. Now, some people have a little trouble with that, but all I did was 3 times 4 is 12. 4 times 1 is 4. 12 divided by 4 gives me 3. But you can put that in your calculator for that. And then what I did was add 7 to both sides, because I wanted to say, here is slope-intercept form. So if the directions call for slope-intercept form, you would stop here. Or y-intercept form. Those are interchangeable. Slope-intercept and y-intercept are kind of interchangeable. Okay, so this is slope-intercept form. So I could graph this. If I were graphing this one, I would start at 4 up here. 1, 2, 3, 4. And then I would use the slope up 3, 1, 2, 3, and over 4. 1, 2, 3, 4. Do you know how to do that quick graph? So there's the graph of my line. Is it slanted to the right? Is the slope increasing?
Yes.
Okay. So a quick graph. Now, if the directions said for you to put this in standard form, which is what I asked you to do, you're going to manipulate this by moving the x value over to the left. You subtract 3/4 x from both sides. But this is not an integer.
Wait, where did you get the 3 from? For the x, the line where it's
Right here, this 3. I distributed 3/4. So it's 3/4 times 4 over 1. So 3 times 4 is 12. And 4 times 1 is 4. And 12 divided by 4 gives me the 3, and it's negative. Okay, so I just multiplied the fractions. So again, this is slope-intercept form. And from there, you can change it to standard form. So pay attention to what the directions ask for. Sometimes it'll ask for slope-intercept form. Sometimes it'll ask for standard form. So I'm going to subtract 3/4 x from both sides. And again, this is not an integer. So in order to make this an integer, I'm going to multiply both sides by -4. I multiplied it by 4 to get rid of this, and a had to be positive, so I'm going to multiply it by negative. So -4 times this gives me 3, -4 times this gives me -4, and -4 times 4 gives me -16. Now I want to pause for just a minute, and I want to look at the other one. When I chose the other point, notice I got the exact same equation, and that was the point. It doesn't matter which of the points that you pick, you're going to get the same equation unless you make an arithmetic error. Okay? All right, let's practice one together.